Yes, Aisha. So see, in the first class, which we had the diagnostic class, where we had the diagnostic test. So we started with this portion. We just had an introduction, right? So electromagnetism's basics, chapters, and what all things are there included in your class 12. We have discussed that. We also started a portion of electrostatics. Do you remember a very small portion we did? What is electric charge? We discussed that, remember?
Yeah.
Okay,
Yeah, I do.
see, let me make you revise this. This part we discussed, remember?
Yeah, I remember.
You have written these?
Yeah.
Okay, you're not audible, Aisha. Just speak something.
Can you hear me?
Your voice is lagging.
So you can't hear me?
Okay, anyways, let's continue. I hope I am audible completely, Aisha. Okay. So see, we had discussed these electrostatics portions. So let me just make you quickly revise it so that we can now start with the basic portion. See, I told you that electric charge is the intrinsic property of matter. When we use the term intrinsic, it means it's the innate or basic property of matter. It's that will give rise to different phenomena. So these phenomena you have in detail. Okay, in your syllabus, you have to study these and tell your electrostatic potential and capacitance. All these portions will be done. So what is electrostatics mainly? It's the study of electric charges which are at rest. We don't move our charge. Our charge will remain static, and whatever phenomena can occur around it, those will happen. SI unit is important. SI unit is coulomb. You will find the symbol C written like this: 5 coulomb, 3 millicoulomb, 2 millicoulomb, 4 microcoulomb, like these, the charges are mentioned. Then CGS unit is very rare. And I also told you on that day that if you see a unit which is electrostat unit, this might come. When you have to convert coulomb and ESU, you can write 1 coulomb is 3 into 10 to the power 9 ESU. This is the conversion that you can make. And this is a scalar quantity. So we can simply add the charges. We need not use the vector laws and everything that we have studied. And I also told you that the types of charges were given by Franklin, where these were randomly just named. One group was positive, other group was negative. So till here we have completed. Revised? Now let me start first. See, now a very important point we have to discuss, that is conservation of charge. Now see, conservation of charges is a very simple term if you see. Even you had it in your 11th, conservation of energy. What was the statement we used to put? Everywhere you must have heard of the statement. Energy can neither be created nor be destroyed, right? The statement you must have heard it in your chemistry also, physics also. Similarly, for the charges also, charges can also neither be created nor they can be destroyed. What happens is charges just get transformed from one body to another. So this is what we have to see, and that's what called as the conservation of charges. Now, if I say electron, see, electrons are particles that are holding some amount of charges. One electron will be holding some amount of charge. Second electron will be holding. The proton will be holding, like this. The amount of charges will be held. So there is a minimum value that one electron holds. And that value you need to remember. That is 1.6 into 10 to the power minus 19 coulomb. Means this much of charge is present in one electron. If I say one electron, this will have minus 1.6 into 10 to the power minus 19 coulomb. And if I say proton, protons are positive. So this will be plus 1.6 into 10 to the power minus 19 coulomb. So this value you should remember till your last chapter semiconductors, this value will be required. So it's better if you remember it, and everywhere you will need. One more thing, Aisha, sometimes you will see only this symbol E is made. So this symbol also represents this term only. Because the full form is electronic charge. Electronic charge means charge on a single electron. So this is electronic charge. Also, it is saying the name is saying that this is electronic charge. But remember, it is valid for both protons and electrons. Okay? Electrons and protons. Now you can write this later. First, understand one concept. See, we have to understand this transfer of charges. And this is the basic part of your entire structure of atom and your quantum physics. See, there is a nucleus, the centrally located nucleus is present. This nucleus has protons and neutrons within itself, right? This is the central core part. Now, these protons and neutrons, they are held very tightly with the help of forces. Those forces are called as the nuclear forces. These are the nuclear forces. Now, the nature of the nuclear forces are such that these forces are very strong in nature. They hold the protons and neutrons very tightly because they are very strong. So they won't allow the protons or neutrons to leak. They are holding the protons and neutrons very tightly in the central core part, which is the nucleus. The nuclear forces, these are strong. Now, secondly, see, nucleus is present, around it the orbits are present. In every orbit, one electron is present, which is revolving. You must have studied structure of atom in your chemistry also, right? So this is similar to that. So what happens is these electrons and protons are not in direct contact with each other. So here the force that exists is the electrostatic forces, which we have to study also. So this is the electrostatic force. Now, the difference lies is that the electrostatic forces are weak in nature. Nuclear forces were strong. So this is the differentiating factor of the nuclear forces and the electrostatic forces. These electrostatic forces, these are weak forces in comparison to the nuclear forces. Like if I give you the data, the nuclear forces and the electrostatic forces have the ratio of 100. Means nuclear force is 100 times stronger than the electrostatic force. So this is the ratio. So you tell me, Aisha, if I give you this atom and I give you this scenario, out of all the particles that are present, which will be easily escapable, which can come out of the atom easily?
The one in the outermost shell.
Voice. Yeah. Your voice is coming. Say.
The one in the outermost shell.
No. Among electrons, protons, neutrons, which element you think can come out of the atom?
Neutrons.
Why?
Because they do not have a negative or a positive charge. They are neutral in nature.
See, I'm repeating this thing. Then you answer. See, in the nucleus, central core part is the nucleus. It has protons and neutrons tightly fitted, right? Why tight? Because these are held with the help of strong nuclear forces. So strong nuclear forces are holding these protons and neutrons. Around these, electrons are revolving. These electrons are held with the help of weaker electrostatic force. This repulsion or attraction, this is very weak. So will electron be easily able to move out of the atom or the protons?
Electrons.
Electrons, right? So not neutrons, electrons. Because your nuclear forces are very strong. They won't allow the proton to go out of the atom. Rather, electrostatic forces could be overcome, right? So one can keep it in your mind that it's the transfer of electrons. transfer of electrons. Okay. And this method of transfer of electrons, like from one atom to another atom, this is referred to as charging. So if you see a term in your NCERT textbook, charging term is mentioned a lot. So as soon as you see the term charging means that this is the transfer of electrons. Protons do not move. So protons will not be moving. Now, when a body, this is an atom. This has lost its electron because electrostatic forces were weaker, electrons could easily be removed, right? So now the body is deficit of electrons, lesser number of electron pockets. So we call those bodies as positively charged. And the body that receives the electrons, they are termed as negatively charged body. Means protons do not move. It's not that when we say a body is positively charged, it has lots of protons, and protons have been added into the atom. They have come from neighboring atom. That's why the body is positive. This concept is wrong. It's the deficiency of electrons which is called as positive, right? And gaining of electrons, obviously, that is negative. It's very clear. Actually, the confusion can occur in this only. Negatively charged body definitely means that electrons are. And if these amount of electrons and protons means positive and negative, they are exactly equal, we say the body is neutral because there is now no net charge. You can neither say the body is positive nor negative, right?
Yeah.
So got this whole concept. Why do we say a body is called as positive or negative?
Yeah.
This is the mechanism. And see, I'll show you a real picture of an atom. Yeah, look at it. See, this is how the central core is present, which is the nucleus. Here you have protons and neutrons. So this is your nucleus. And see, these are actually how the orbits of the electrons are present. These are the electrons that are present. So this is how the atom is moving, and they are held. See, they are held very tightly. You can see also in the figure because of the nuclear force. And they are far away and they are attracted because of the electrostatic. Okay? All right. So we will see this concept of charging in detail. You have charging, you have some methods of charging in your syllabus. 3 methods of charging are there that we will see later. First, you copy it till here. Okay? From here. I hope you have the portion above.
Yeah, I do.
Just write, let me know done. I'll scroll it.
Okay. And can you scroll down? I'm done.
All right. Now let's see this process, that is charging, a little in detail, because few things are there that you should know. See, when the question comes, these are the things that make the difference in your answer. You should, if you know everything from the scratch, then the questions also will be handled well. See, the questions come from methods of charging, the portion that we'll be doing after. But the conceptual questions, because now MCQs are also there in your board exam. For the MCQs, from here you can revise it. Okay, before this, those were just general questions. They are usually not asked in your exam. Now see, just before we go into the detail, see, let's take this example. This is object A. Let's say this is atom. This is the nucleus of the atom. This has 4 protons and these are the electrons. So as I told you, let's calculate the charge. As I told you, the electronic charge is E and the protonic charge is also E only. That is 1.6 into 10 to the power minus 19 coulomb. So when I'm calculating the net charge here, look here, 4 protons are present. This will be plus 4E. 4 electrons are present. So this will be minus 4E. So what will happen? This will get cancelled. Net charge is 0. Right? Okay, one more thing. These electrons are not massless quantities. They have the masses. Mass of electron is 9.1 into 10 to the power minus 37 kg. This much of mass is present in a single electron. So if I have 4 electrons, 4 mp is the mass. Right? Now you tell me what's the net charge here in this, the way I've calculated it for here.
5 electron. No,
My,
4 electron minus 5 electron.
plus 4e minus 5e. So see, we are left with minus e.
Yeah.
And see, the mass of electron will be this time 5 mp. I'll tell you what we are discussing. And tell me the charge at C also.
4 electron minus 3 electrons
Which is equal to
plus E.
plus. Exactly. And mass is 3 m. Now look at the conclusion. This had 4 electrons and 4 protons. So this body was neutral. Mathematically also we can see the body is neutral, and these were the masses of electrons. I have written ME, mass of electron, and the mass of proton. It's the mass of electron. Because we are right now considering electrons only, because protons are not transferring. Now I
Hmm.
just added 1 electron to this neutral element. So gaining of electron, you can see by the calculation also, it made this body negatively charged, right? But what
Yeah.
happened? Mass of electron became 5 ME. Means the associated mass of the electron also came. If electron is
Hmm.
coming, it won't leave its mass back. Mass will also be along with the electron.
Hmm.
And when we had, suppose we removed 1 electron from this neutral. So this created deficiency of electrons. That means positively charged body. And you can see that from the calculations also, you're getting positively charged body. So what is happening? The mass is now also 3 times m. So what the questions can come in your exam is just basic questions are present. Like when a body is negatively charged, what you need to remember? First of all, you need to remember that the body is negatively charged because of gaining of electrons.
Hmm.
Gaining of electrons. This is how a body has become negatively charged. Also, the most important point, the mass of atom increase. The mass of atom will increase. Whereas when you're talking about a positively charged body, this is formed by loss of electrons,
Electron
right? And the mass decrease.
decrease.
These are the conclusion points that we need to remember. Now, there are 3 methods by which this charging can occur. Those are important for you from the boards. And see, one is charging by friction, second is charging by conduction, then charging by induction. I'll start with charging by friction right now. First, you copy down this.
Okay. Completed. Yeah, I completed that also.
Okay. Now let's move to the methods of charging. So first method of charging. So first method of charging is basically charging by friction. Now, what do you remember about frictional force? You tell me. Then I'll add on point. Because friction force is not new. You studied?
It is an opposing force.
Yes.
It acts in the direction opposite to the acting force.
Yes. To the motion of the body. Right.
Yeah,
And it's a contact.
force. Yeah.
Whenever there is a contact, then only the friction force will be there. So right now also this contact property of friction is important. Here what we do in charging by friction, see, electrons and protons and everything is present. The last electron in chemistry, I think you must have heard that this is called as a valence electron, the outermost electron.
Hmm.
So when ionization and energy and ionization potential, anything is targeted, then these valence electrons are in. So when we're talking about charging by friction, so charging by friction, what we do, it basically opposes the movement. Means whatever is the movement, whatever is the motion, frictional force will be in the exactly opposite direction. This is what we have studied from our previous concepts. Now, in electrostatics, see, frictional force much is see the context of frictional force and the theoretical part of frictional force is the same. But in electrostatics, we don't see how the frictional force is acting or when does the friction force act. You have to remember it opposes direction, right? So right
Hmm.
now, what will happen? We take two bodies, you rub the two bodies against each other. To take
Hmm.
two spheres, take two conductors, rub them against each other. Whatever will be the work done against frictional force, because see, irregularities will be present, the bodies will get in contact with each other. When they'll oppose each other, the movement will be generated, and because of which a frictional force will be present. So this frictional force is present in your system right now because of the motion. The work done to overcome this frictional force, this allows the electron to get transferred. Okay. Now this is just a statement and that's it. That's what is there in your charging by friction. But what kinds of questions can come? What all types of questions can come from charging by friction? So for the question part, first let us understand something. Okay, I should tell me the net charge on the body. A,
0.
0. Because it is 4E minus 4E, 0. And what's the net charge on body B?
0.
0. 5E minus 5E. This is also getting cancelled. This is also 0. So both are now neutral bodies. We cannot say this has an extra electron or this has an extra electron. Both of these bodies are neutral, right? Now, if I give you a condition, if I say that Aysha B has strongly bonded electrons, so you tell me if the electrons are very strongly bonded here, will electrons be easily escapable from A or easily escapable from B?
From A.
From A. Because B has strongly bonded electrons. So it is holding the electrons tightly. So definitely electrons will A from A body will be going. So now what will be the charge signs on A and B? Like if electrons are moving according to you from
A
A
will
to B.
be it will be positive.
Yes, A will be positive. It is allowing the electrons to move. No? It is having lesser number of electrons and B will become negative. So questions come in this manner. They will ask you, they will not give the statement directly. You will read the statements and at the end you have to just tell what are the signs. So this logic only you have to apply. What is the logic? Just one logic. That's C. Easier if B has strong bondations. Then easier is the removal of electrons from A. Now, why does this happen? Because of conservation of charges. See, initially 4 electrons are present, 5 electrons are present. Total 9 electrons are present. Now, even if 1 electron goes from this body to this body, still total number of electrons will be 9 electrons. In order to maintain the conservation of charges, this process occurs. And 2 more points, Aisha. See, for every body you cannot remember. There are so many objects you cannot remember. But in NCERT, 2 things are mentioned. So it's better if you remember these two, just in case if it comes. Glass rod and silk cloth are very important because this was the experiment which led to the discovery of the charges. So glass rod acquires positive charge and silk cloth acquires negative charge. Now you tell me if this is the scenario which I am mentioning, electron transfer has occurred from which body to which body?
From glass rod to silk rod.
Yeah, right. From glass rod to silk. That's why this is positive, this is negative. Similarly, woolen cloth acquires positive charge and plastic rod acquires. This much you can remember just in case of a question. Out of these two also, glass rod is of much importance. Okay. Now we have a question. So you write down this part first, then I discuss that.
Can you scroll down?